I want to talk about the compression of images. So when you save a image, you're actually using a compression technique. Let's talk about one of the simplest, a bitmap. A bitmap is an image that's only black and white. So let's suppose on your monitor we had a very tiny image, and it only used 8 pixels on your screen going across and 16 pixels down. Now that would be a very tiny piece of real estate on your monitor, but let's suppose that's what we had. Each pixel on your monitor needs 1 bit behind it to store the necessary data for that pixel to be on black or off white. Well, that means that I need a total of 1 total byte per row and 16 bytes to store it. So if I had an image called sample.bit, sample.bmp, and it was a bitmap, and it was 8 by 16, when I saved it on my disk, it would take 16 bytes of storage. Remember, each pixel only needs 1 bit behind it to store the data that would be indicative of that pixel being on or off. Okay, now, if I took the same image, 8 by 16, and I resaved it as a GIF, here's what we have to know. Each pixel of that 8 by 16 image has the ability to store has the ability to represent 256 different predefined colors. Each color in a GIF image, each color has an assigned value from 0 to 255. Since a byte can store up to 256 different values, we can store up to 256 different predefined colors. So in other words, if you had an 8 by 16 image, each one of those pixels would now need 1 full byte or 8 bits behind it so that it could be stored as a GIF. An 8 by 16 image now would use 128 total bytes of storage. How do I get that? Well, each pixel in an 8 by 16, that's 128 different pixels, needs 1 full byte behind it. 1 byte, 8 bits behind it, so that we can actually reference one of those 256 different predefined colors. So a GIF does have colors, but the only colors it has are the 256 predefined colors that can be represented. Now, why is this lossy? Because let's suppose that I'm trying to represent a shade of red and I don't have that shade of red in my 256 predefined colors. Then I have to substitute something that I have close to that. Well, that's what we mean by lossy. It's not perfect. It's not the same as the original. So a GIF basically is a lossy way to store color, store images. Now the third way is a JPEG. This is well, there's a lossless mode, but many people don't use that. There's a lossy mode that seems to have become the standard. So this lossy mode is designed to take advantage of human eye limitations. So certain things our eye doesn't pick up, and this JPEG lossy mode takes advantage of that to actually allow us to store the images. So the result is a significant decrease of a significant degree of compression without a noticeable loss of image quality. Now, how does this work? Okay, I've got 8 by 16 image, and each pixel on the screen needs 3 full bytes behind it. Where do those 3 bytes store? Well, 1 byte is a byte that has 256 shades of red. Another byte has 256 shades of green, and another byte has 256 shades of blue. And what we have to understand is that 70 times per second, there's like these three guns shooting so much red, so much green, so much blue at one of these pixels, and it gives its color. Now if you take 256 multiplied by 256 multiplied by 256, you're going to have over 16 million colors that are available in a JPEG method. However, if you took our simple 8 by 16 image and you stored it as a JPEG, that would require 392 bytes of storage. Now, these images could all look exactly the same, and as a bitmap, an 8 by 16 takes up 16 bytes. As a GIF, if we save the same image as a GIF, a black and white image as a GIF, it's going to take up 128 bytes of storage. And if I save the same black and white image as a JPEG, it's going to take up 392, because now each one of those 128 pixels needs 3 full bytes behind it, 1 byte for red, 1 for green, 1 for blue, to allow it to store over 16 million colors.